So we also need to distill the burette. So the first thing, if I put in there, then I take some clean water, with this the distilled water. Oh, right. Then we move this one. So the first thing, we take away again the burette so that we can clean it. So the best way to clean it is go like this. Then we start to rotate it. If you are rotating it, you are cleansing it, you are cleansing it, cleansing it. That's the method. But then you leave some so that you also clean okay? Slide this fine again. Throw it out. So my burette now, I understand it's now clean. Then I go put it back quickly. Right, so I'm going to put, I want to make it in acid to base, so let me put the acid in there. So I don't know if we are going to have an end point. Like I told you, we never prepared these solutions.
Oh, sorry.
So we're supposed to have what we call a volumetric flask. It's the one that we use. We don't use this beaker. But I don't see the volumetric flask. It's the one that we pour in. Is it in there? The one. It's not there. I just try to do it. Yes. But we need a volumetric flask.
Things are going to struggle here.
No way we can lower this thing. Put it down lower.
Again.
When I'm saying you can take this and put it that's on the floor, you can throw it like that. It forces
Maybe.
it will help.
Maybe. So I'm using the wrong equipment, but I'm just trying to do it. Then again, there's a tendency, there's a tendency that the water will collect there. You have to lift it up a little bit. I suppose when you see the water, because if I pour it like this, the actual funnel that I was using, there are times when the water will just stick like this. Right? And it's no normal thing. Right. So I just want 50. Right. Then also, of course, we understand the issue of meniscus.
Yeah.
So whenever we are dealing this, we have to make sure.
Do you want to put it back?
Yeah. Right. So we now have our acid and we have our base. Then whenever we have our base, we are going to use the conical flask. So what we do, we have to pipette. This is our sodium hydroxide that I'm comparing against this sodium hydroxide. So the best way, we all know we have to be pushing it upward like this. So it now depends how much are we going to take. So basically I want to take 25. Okay. Let's say it's too much, you've taken too much, you have to press this one. So that you put it back. Put it back. Okay. So here I just need there's a danger because the pipette is very accurate. There's a danger that people tend to use the measuring cylinder because they don't want this because it's tiresome. They just take and pour in the measuring cylinder and they measure using the measuring cylinder. They say it's 25 cubic centimeters. But there's a chance that because this one is more accurate than the measuring cylinder. Okay, so I have 24 here. Let me just try. There we go, it's not 25. But please remember, we are not sure if we're going to reach end point because our mixtures were not properly done. I don't even know the concentration right now. Okay. Alright. So the next thing, we take, this is phenolphthalein. In this case, this is the indicator. So the indicator, we're supposed to put it in the base. So usually phenolphthalein, when you put it in the base, it depends, but it must change something like it's pink kind. So I'm going to put maybe 5 drops of phenolphthalein. Okay. There we go. So we now have our solution. So basically, this is what we are supposed to be doing. Then we go, now titrating. So this is the titrate and the titrate. In this case, so at times it might be the opposite. You might be using the base, the one going to the acid, but in this case, it's the acid going to the base for this reaction. So when there is color change, that shows that the reaction is done. Okay? So I don't know if you're going to reach any color change because we just, so this is just a rough tight. Okay. So the color was pink. And again, here usually I think you have the child. You're supposed to put a white child there so that you can quickly see the color change. People notice this shape. And it seems we're gonna go and go. Yes, if it neutralizes, it's supposed to change its color. No, it must come to colorless. In this case, yes. So this one is called the rough tight. Of course, I have to do many experiments, not just one, so that you'll be measuring the